Hey everyone, thank you for joining us today. My name is Omri Greenberg and I'm the co-founder and COO of OneView. I'm here to talk to you today about synthetic data. What is it, why do we need it, and how it could help us improve our image analysis processes. I want to start right away with the biggest issue geospatial images are suffering from. And this is the fact that the geospatial image analysis is severely bottlenecked. It's not just a bottleneck, this is a data bottleneck. And this is happening because of the major role that data plays when training machine learning algorithms. Before we jump right in, I want to present how machine learning models are being trained today. So in the very general perspective, we have four major steps. Starting from the data collection to the data annotation, then we can proceed to the model training and its deployment. As we are a bit short on time, I want to focus on just the first two steps to better understand our problem. So the first step is the data collection. Every machine learning algorithm requires huge amounts of data in order to be properly trained. But it's not sufficient just to have large amounts of data, rather than we need to have the right data for us, meaning it has to be relevant to our use case. It needs to be consistent from our sensor, from our objects of interest in our area of interest. But also, in addition to that, we need as much diversity as we possibly can. So in real time, we would be able to handle, tackle, or detect any use case that we might encounter. Those 3 points, the large amounts of data, the relevancy of the data, and its diversity are leading to two major issues. The first one, is the ongoing shortage of data. We are on a constant hunt for more and more data. Any change that might happen if we want to utilize a new sensor, we want to add a new capability and detect a new type of object, is forcing us to repeat this process of the collection again and again. The second one is our lack of ability to answer edge cases. And here let's take an example from the autonomous vehicle domain of a kid jumping into the middle of the road. As this is something that doesn't happen too often, luckily for all of us, we probably won't have enough data in order to detect that kid in real time. But also more day-to-day tasks falls into this category. What if we need to distinguish between one type of an insulator to another, or we want to classify very unique classes of aircrafts? The granularity the real data has in the real world is not, we won't be able to collect all of those images to properly train the different models. After we completed the collection phase, we can move on to the annotation. The annotation phase is a step that is being done manually by human annotators. By default, this step takes lots of time in order to be completed because we need to be able to annotate a very large amount of data. But it's not just the annotator's time that is being wasted here. Also, the data scientist needs to invest precious time as well. He needs to define the right process. He needs to constantly review it. And more often than you think, also manually correct annotations by themselves. And because this is also a human in the loop process, there's a lot of room for human errors, especially in our industry, where the resolutions are fairly low, the objects are small, and images cover very large areas. It is really easy to make annotations mistakes. And those mistakes translates directly into poor results of your machine learning model performance. So I hope that by now I've convinced you that indeed we have an issue here, and this is a true pain, and we have a data issue more precisely. So how can we solve this data issue? We believe the solution comes from a new type of data, or more precisely with synthetic data. Now synthetic data in a sentence is data that was generated in comparison to the actual collection and annotation of real images. And let's take a deeper dive into what is virtual synthetic data. So those are images that were generated by the computer as they were made in the virtual domain, so they could come also fully annotated. And as there's no human in the loop, they are error-free, or as we like to call it, pixel-perfect annotations. The goal of these images is to replace real images in the training process of machine learning algorithms. We believe this method could also solve the availability issues, as you can generate as much data as you want according to your needs, but also the production issues, as the data already comes ready for training and you don't have to invest any more manual effort after its acquisition. Since we have control in the creation process, we can generate the data sets to be optimized for training machine learning models. And because we've mentioned the creation process, let's have a quick review on how we at OneView are building our synthetic data. And there are a few methods in how to create virtual synthetic data, but I'll present just the one that we are doing here at OneView. So we start by creating 3D worlds by using gaming engines. That allows us to have full control of every parameter. We control the different scenes that we're building, which objects we're placing and where. We control the sensors' characteristics and their viewing angles, and pretty much any other important features that you might think of. To that 3D world, we are adding a lot of real-world attributes, such as different weather conditions, different times of day, different season of the year, and so on. From that 3D world, we are rendering 2D images that mimics the specific characteristic of your sensor of choice. We then, by using post-processing procedures, we are adapting and transforming the data to have the right look and feel of real images, and so it won't appear like an image that were taken from a game, for example. The last phase is obviously the annotation. As we operate in the virtual world, and we are the one that have placed the different objects, and we know where and what have we placed, we can also automatically generate the pixel perfect annotations, meaning you don't have to settle anymore for the quote unquote regular bounding boxes. You can now instantly get semantic segmentation masks. And this is without any human in the loop. So our annotations comes fully error-free. In all of this process, we are adding a lot of randomization features. So our data would be as diverse as we possibly can, but still realistic, so it would be able to operate during real time. The end result of this process is a ready for training dataset that was custom according to your demands. We believe that this method will be the true enabler for our industry, and I want to present also a few reasons for why is that. Starting with diversity and balance. When handling with real images, you actually can't really know what your data consists of until you have completed the collection and annotation phase. You can find yourselves with just a few instances of your object of interest, or maybe with a very biased data set. The randomization on the one hand allows us to create very diverse scenarios in the virtual domain, but also the control allows us to define not only what objects we're placing, but also how many of them we're going to allocate. So now you can define how many instances you want and how many instances you need against you're hoping to find them in real images. Moving on to the scale and adaptation. So as we said earlier on, the collection and annotation phase are a very long process. And this is what's holding us back as an industry to be much more agile. And we believe that the synthetic data solves exactly that. If you want to expand your capabilities, if you want to support more use cases, you can easily create them in the virtual domain. You can do that by adding a new sensor parameters. You can do it by ingesting a new object model, and so on, and be able to support much more use cases and adapt to the emerging needs and to adapt to the drift in data that often occurs. The last but not least is the ability to cover edge cases. Again, the synthetic data and the virtual world allows us to generate scenarios that otherwise we won't be able to create. Now we can generate enough data in order to detect that kid in real time, or even just classify the airplane to the right type, because we have generated those scenarios, those images in the virtual world, trained them, and found them on real time on real images. So by now you've learned, you've learned what synthetic data is and why do we need it. And you're probably wondering, is it good enough? Can it actually be an alternative to real images? So the short answer for that is yes, and I'll elaborate by presenting a use case we recently worked on. And in this use case, this use case was for the detection of oil spills from oil pumps and from oil pipelines. One of the largest oil and gas operators in the US is suffering from occasional leaks from the oil pumps and from the oil pipelines. They have a vast network of remote sites spread across the US that they are trying to monitor using a manned aircraft and analyzing the images that were captured by it. Since there is huge amounts of data flowing in every day, to do manual interpretation for all of the data is not feasible. They have also tried machine learning methods, but they didn't have enough data in order to train their models because the appearance, of those leaks is quite rare and they didn't have enough data. So their solution was to utilize OneView's virtual synthetic training data. They have defined pretty much every parameter in the data set, what type of sensor they're using, the type of the environment, what's the weather condition, their objects of interest, of course, and we have created a data set that was custom to their needs. Their main goal was to improve their oil leakage detection results, but also it was important not to harm the detection rates of other objects of interest as well. And the main challenge, as I said, that they didn't have enough data in order to do that. As you can see in the table below, they had 563 instances of real oil leakages. But it's important to understand that most of them were duplications of each other. By creating an additional 8,000 plus leaks that each one was different from another by the size, by its orientation, by where it was placed, and even the color and density of the liquid, we were able to create a sufficient amount of data so they would have a proper training data set for their needs. So from our experience, we know that the best way to utilize synthetic data is by doing a mix of synthetic images alongside with real images. In this slide, you can see a comparison between the two methods. In dark blue, it's only the real images, and light blue represents for the mix of data. So as you can see, when using a mix of our synthetic images alongside with their real images, they have more than tripled their detection results of the oil leakage. But also they did it without compromising on accuracy on other objects of interest, as you can see on the left side for each graph. By using the standard result metrics, you can see that their detection rates were up by more than 30%. Now you have to agree that this is something which is really impressive. So before we wrap up this session, we wanted to say that we are not the only ones believing in the power of synthetic data. As we are focused on the remote sensing industry, you can now find synthetic data in many more applications, in autonomous vehicles, in smart stores, augmented reality, virtual reality, and basically any application that requires image analysis in order to extract insights. So if you would like to learn more about synthetic data, please come and visit us at our virtual booth, and I'll be happy to answer some of your questions now. Thank you very much for listening. Have a good day.
So I saw a question about what kind of gaming engines are we using. So actually, we're using the Unity gaming engine, but not only that, we're using several tools such as 3ds Max, Houdini engine, for example, for procedural generation of our data. And there's a lot of to discuss about that, so I'll be happy to elaborate over a call in our booth. In addition, I saw, do you need any special expertise? No, so actually you can define the data, the type of data that you want us to generate for you. So you can define the annotation type, the output type, the formats of the annotation, and pretty much everything. So it goes and happen to be like a plug and play data as you're familiar with. Let's see, are there any more special questions here? Let me scroll. So as the results, Abu Nadav, we presented how we can replace and also add to the results when using synthetic data in the use case that I've presented. I hope that answered your questions. And morning question, how can you train something when it's not clear what you're detecting? Actually, we need to understand what you want to detect. So then we can generate the data needed for that. If we don't know what's needed to detect, so it would be difficult to design and generate the data for that as well. So I see that we have run out of time. Please come by our booth. I'll be there alongside with my co-founders to answer any of your questions. Thank you very much for having us. It was great. Please come by. Thank you.